Hello everyone and welcome to another Advanced Hard Maths differentiation video lesson. This video we're going to take a little look at finding the first derivative of a function defined implicitly. Right, now that's going to sound quite daunting, but don't worry, the first thing we'll look at is what the difference between an implicit and an explicit function is, so that you'd be able to recognise an implicit function and then employ that technique to differentiate it. The last two success criteria points there are just about the how. You need to know that differentiating a term containing y with respect to x, and then how to simplify the answer fully. Okay, so let's take a little look at the first point there. Now, when we have two variables, most commonly x and y, what we can do is say y is an explicit function of x if it can be written as a clearly defined function of x, right? So this means that we can write y as an expression in which the only variable is x. So like the straight line equation, y equals 3x add 1, or a trig graph, y equals cos 3x minus 4. These are explicit functions. They are explicitly defined as y in terms of x, okay? Or just one variable in terms of the other. So, and these functions you've been working with throughout higher maths and how to differentiate them, you're well aware of now. However, an implicit function, you have come across an implicit function before. Notice the bottom equation, right? You should recognise that there as a circle equation. But an implicit function for two variables x and y is one when x and y are not written explicitly, but as functions containing x and y. Okay, so for instance, the circle equation x squared or y squared equal to 1, for instance, that's written as in terms of both the variables x and y. So we can differentiate that using implicit, or those are implicit functions which we differentiate using the techniques for implicit differentiation. So that's the difference between them. Here's the how to differentiate it. That'll probably be second. Okay, so basically to differentiate an implicit function in terms of y and x with respect to x, so we're finding dy by dx, the derivative of y with respect to x, for an implicit function that's written in terms of both variables. Well, if a term, right, it's really say if a term rather than if a part, but if a term only involves x, we differentiate it as normal. So if there's just a term of x squared, then you differentiate it as normal, you get 2x. However, if a part involves y, what we do is differentiate it as normal, but chuck in a dy by dx after it. Okay, now that must sound quite odd, but you'll see exactly what I mean in a wee second when I do an example one with you. But essentially, if a term's got a y in it, differentiate it, but chuck dy by dx with the derivative of that term. Right, and we'll take it that way. So let's have a look at this one. Right, differentiate 4y squared equal to 4x cubed, take away 3x squared, add 2y. So this is the sort of thing you would have to differentiate implicitly. Okay, it's written in terms of both variables. It's not explicit as in y equals, so we'll have to employ some sort of different implicit differentiation. So the process is the same as for any other derivative. You are going to take each term and differentiate each term. Okay, so let's start with 4y squared. Well, that's a term containing y. So we differentiate it as normal, and we have 8y, but that's now 8y dy by dx. Right, so that's what that second point in the last slide there meant. You differentiate the term as normal, but put dy by dx with it. So 8y dy by dx. The next term, 4x cubed, well that's just a term in x, so we'll differentiate that as normal, 12x squared. Differentiate the second term as normal, but the final term is a term containing y. So we're going to differentiate it, but put dy by dx with it. So the derivative of 2y would be 2 and then we have dy by dx. Now, the aim of the game here is you've now got, your derivative has two terms containing dy by dx. So the aim of the game here really is to get the dy by dx's collected over to the left hand side, so that you can express the derivative as dy by dx equals. The derivative will be implicit, it will be defined in both x and y, but that's okay, so long as you get it to dy by dx equals. So that's the last success criteria, is getting it fully simplified. So what we do is we want all the dy by dx terms on the same side of the equal sign. So we'll take, we'll get rid of this term by taking it away. So this will be 8y dy by dx, take away 2 dy by dx, equal to 12x squared, take away 6x. Right, so we carry on. The next step, once you've got all the dy by dx's on the same side, the next step is to take dy by dx as a common factor. Right, and you should be able to see where this is going now, because I can get dy by dx on its own by writing it like this: 12x squared take away 6x all over 8y take away 2. Okay, so that is the process of getting to your derivative using implicit differentiation. You're going to differentiate each term, finding the derivative of a term containing y, putting dy by dx with it, and then differentiating x terms as normal. The only thing you need to do is check if your final answer simplifies down. So this is an algebraic fraction. We're going to have to look for common factors, and we can see there each of the numbers, each of the coefficients are all even, so at least going to be a simplification by 2 on there. Let's just take the common factor out for the numerator, and we get 6x bracket 2x take away 1 over 2 4y take away 1. 2 goes into 6 3 times, and we'll end up with 3x 2x take away 1 over 4y take away 1. Okay, so the steps are hopefully pretty clear there. Okay, find your derivative, terms containing y, you get dy by dx put in, bring all the dy by dx terms to the left hand side, common factor the dy by dx out, and then rearrange and simplify your final derivative. Let's look at this one. Y squared take away 3x equal to 4 squared. So let's just dive straight in again, differentiate each term. The derivative of y squared there is going to be 2y dy by dx take away 3 equals 8x. Okay, so this one's actually much easier. There's only one dy by dx term there, so no need for common factors or anything. We'll just rearrange the subject really and get dy by dx equal to 8x add 3 all over 2y. Job done. Right, there's nothing much more you can do with that there. There's no common factors, no simplifications to be made, so quite straightforward. Now, this one, however, right, when one part of the function has both x and y in it, what we have to do is use the product rule. So what we're talking about here in this example is the 3xy term. That term has both an x and a y in it. So what we have to do is treat that as 3x times y and use the product rule to differentiate that term. Okay, so let's have a wee look here. What have we got? We've got the first term is our product rule term, so let's do a little bit of side working. Right, so we're differentiating 3xy, u will be equal to 3x, u dash to be equal to 3, v will be equal to y, v dash to be equal to the derivative of y. Now that's just treated as 1y, so if you think about it, the derivative of x would just be 1, So the derivative of y would just be 1, but we need the dy by dx with it. Okay, so we don't need to, you don't need to go as far as writing the derivative of 3xy, but doing a little side piece of, because you can do that in the expression in the main part of your working. But if you do the prep work with listing your u's and v's at the side, it'll just help keep you right. So let's start our derivative. It's going to be uv dashed, so 3x dy by dx, plus vu dashed, so plus 3y, and those first two terms are the derivative of 3xy. So let's differentiate 5y squared, so we'll get 10y dy by dx, take away 2x, equal to 2 dy by dx. Okay, so we've got lots of dy by dx terms there, but you just do the exact same thing as we did in the first example. Bring all the dy by dx's to one side, all the terms without dy by dx to the other side, common factors, and simplify. So our next line of working might look something like this: the 3x dy by dx term plus 10y dy by dx, because the 3y term is going to go to the other side. The take away 2x term is going to go to the other side, but we're going to have take away 2 dy by dx equal to 3y, no, not 3y, get that the right way around, equal to negative 3y plus 2x, or you could write it as 2x take away 3y, won't really matter. Common factor of dy by dx, and we'll get 3x plus 10y take away 2 equal to negative 3y plus 2x, and then divide. I'm just going to write it as 2x take away 3y because it's upsetting my OCD to lead with the negative term. So 2x take away 3y over 3x plus 10y take away 2. Job done. Alright. So terms containing, as I say, terms containing both x and y need a product rule to find the derivative of. Okay. Last example, let's have a look. We can obviously use implicit differentiation to find the equation of a tangent to a curve, which cannot be written explicitly. So you would usually find the equation of a tangent to a curve at higher by finding the derivative of the curve. That gives you a function for the gradient. The x coordinate goes in, you calculate the gradient at the given value of x, and then you calculate the, and you would maybe have to work out the y coordinate and then plug it all into the straight line equation. We're going to do that exact same process as you had for higher with this, but the technique for differentiation is going to involve implicit differentiation, because that equation there is written implicitly. So let's start with the derivative. Right, we've got our points, we don't need to find the y coordinate. So all we need to do is find the derivative, plug in 2, get the gradient, and find the straight line equation. Okay, so let's go about this. Let's have the derivative. That's 2x plus, then we need to use the product rule for finding the derivative of 4xy. So let's do the prep work over at the side. U is equal to 4x, v is equal to y, u dashed is equal to 4, v dashed is equal to dy by dx. That's fine. So we've done our prep work. So this is plus uv dashed, so plus 4x dy by dx plus 4y, and that's the product rule part complete. Then take away 2y dy by dx for the derivative of y squared, and that's equal to, well, the derivative of 16 is 0. Okay. So keep the dy by dx terms on the left hand side, move the 2x and the 4y terms over to the other side, so we end up with 4x dy by dx, take away 2y dy by dx equal to and we'll have negative 4y, negative 4y, negative 2x. Okay, now nearly there. Let's just get the common factor out, see what we get. dy by dx, bracket 4x take away 2y, equal to minus 4y take away 2x, and then divide. dy by dx divided by 4x take away 2y. We better simplify this, so let's take common factors. I'm going to take a common factor of minus 2 out on the numerator. So minus 2, and then that'll be 2y plus x over, and I'll take a common factor of 2 out on the denominator, and I'll get 2x take away y. They obviously cancel out, and what we're left with is negative, because that's a negative divided by a positive, so negative 2y add x over 2x take away y. And that's the derivative, folks. Now that we have the derivative, right, we need to find out the gradient. Right, so you'll remember probably writing it higher, m equals dy by dx. Right, so at a given value of x, you would work out the gradient, but our derivative is defined implicitly. It's got x and y in it, so both the x and y coordinates need to be subbed in. So since they're both 2, a was a point 2, 2, remember, then we'll have negative 2 times 2 plus 2 over 2 times 2 take away 2. So that's 4 and 2, 6. 4 take away 2 is 2. Negative of that, so negative 3 is our gradient. Okay, so we've got m equal to minus 3, we've got 0.22, so straight line equation from higher, y minus 2 equals minus 3, x minus 2, and take it there, so you'll simplify this, minus 3x plus 6 plus 2 plus 8, there we are, job done. Okay, so that's our implicit differentiation process, folks. Don't forget that when you're finding the derivative of an implicit function, all you're doing is taking the derivative of each term as normal. If it's only containing x, just differentiate it as you would always do. If it's only containing y, differentiate as you would normally do, but put dy by dx with the term. And if it's got both x and y in it, use the product rule. Okay, and if you follow that, you really shouldn't have too many issues with this. You know, it's generally found to be not too bad. So thanks very much, folks, and I'll see you in the next video.